Okay, so let's go from the beginning. Just give me 2 minutes to explain the previous concepts so that it gets recorded again. Okay, okay. So as I told you, in this class we were discussing about rank order clustering algorithm, and here this algorithm will be used for arranging the machines and the arranging the machines in some group, or we call it a cell, depending upon the components what you are going to manufacture. So the basic idea is to arrange them or put the machines in one single cell, or in multiple cells depending upon the product what you are going to manufacture. So here, as the name indicates, it's rank order clustering algorithm. We are going to assign some binary values, or we call as binary weightages, to the arrangement, and based upon that arrangement we are going to classify them as we are going to find the weightages for the rows and the columns. Then we will be segregating them into some groups. Okay, so we are going to do this and we are going to segregate this. So let's see the problem. So before going to the problem, I told you you should be able to understand or memorize these values to make the process simple. So 2 power 0 is 1, 2 power 1 is 2, and so that 2 power 12 is 4096. So this is the this one you have to remember before proceeding to the problem. Okay, so only when you remember this, the task becomes very easy. And I will tell you why I have arranged it from right to left. So that is very important for you to understand. Okay, problem where I have given this problem. Imagine this is a matrix where it denotes where there are two parts. One is machines and other one is parts. So here there are in this problem there are five machines. To differentiate the machines, I have given them in different color coding for you to understand. M1 in green color and M5 in some brown color. So this will help you to understand or differentiate the rows. Okay, so here the machines denote the rows, whereas the columns from 1 to 10 they denote the number of parts. So in this case, machine 1 is being utilized by part number 1, 2, 3, 4, 5, 7, 8, 9, 10. Similarly, part 1 uses machine number 1, machine number 3, and machine number 5 for manufacturing. Machine number 10 uses, sorry, part number 10 uses machine number 1, machine number 2, and machine number 4 for manufacturing part number 10. Okay, so as you move along the rows or the columns, you can identify which part uses which machine, or which machine is required for manufacturing the particular component. So this will make you to understand this concept. So now what we are going to do is we are going to group this machines in particular way, or group the components in like we are going to segregate the parts and the machines based upon their usage. So to do that, what we are going to do is, as I told you, this is called a rank order clustering algorithm. What we are going to do is we are going to assign some binary weights. So when I say binary weights, and this is rank order cluster algorithm, remember that rank means R stands for rows. So first we start with the rows, next we go for the columns. So clustering, C, RC, remember this word RC, so rows and columns. Okay, so first I start with rows, next I will go with columns. Okay, so what to do that, what we are doing, we are assigning the binary weights from left, so from right to left. Okay, so we are assigning the binary values from right to left. So my students, they make mistake here. What they will do is, the problem is easy, they will allocate 2 power 0 and 2 power 9 over here, so they will end up in wrong answer. The solution, you will get a solution, but the final answer will be wrong. Okay, so be cautious. You should start from right to left, assigning the binary values from right to left. Okay, so by assigning the right to left, we will can solve this problem. So say for example, the part number for machine number 3, it's 2 power 3. What is 2 power 3? What is 2 power
8,
3?
sir.
8. 2 power 4?
16.
2 power 5?
32.
2 power 9?
4096.
4000. Just check.
512.
512.
512, 512.
512. So if you could add all these values, you'll be having 568. Okay, when you add all these values, you'll be having 568. So what we are doing is we are just assigning. So wherever this one is there, that denotes that that particular component used to by that particular machine. So it will be always in ones and zeros. If zero is given, that means or if the if nothing is given there, that denotes that that particular component is not using the machine. So substitute this 2 power 9 to the respective places and add everything together so that you will get the decimal equivalent. So now what is the task? So now we have to, I told you it's going to be ranking. Okay, so now what we did, we found the values and we need to rank these values. So can you tell me among these five values, which is the greater one, which is the highest one, highest value, highest decimal equivalent?
1020.
1020.
So that is machine number 5, correct? That is machine number 5. What is the second one? Second highest?
1007.
1007.
Next one?
568,
Next?
455 and 4.
455.
Okay.
Last is 450.
Okay. So now after doing this, what we have to do? I told you we are going to rearrange this. Okay. Now you know we are going to rearrange this based upon the decimal values from higher value to the lower value. Okay. So what I did, I just arranged the machines depending upon the ranking what you give. Okay. 5, machine number 5 will be the first one. Machine number 1, machine number 3, machine number 4, and machine number 2. Okay, so based
Sir,
upon
if the values are equal, then
if the very good question, if the values are equal, it will be up to you to select the machine. Like say for example, if both machine number 2 and machine number 4 are having 451 or 455, it's up to you to select department number 4 or department number 2 to be placed. Okay, it's up to you, because if the values are decimal equivalent values are same, it doesn't impact much. Okay, now what we are doing, we have arranged this rows depending upon the decimal values what we got. So now what we did, as I told you, rank means rows. So R stands for rows, C stands for column. Just this is just a hint for you to remember. And the next thing you have to do is you have to always remember to do from left right to left, right to left, then we arranged it and we got this value. So now what will be the next step? We are done with the rows, we have to now go for the columns. Okay, you see, so now we have rearranged it for the rows and now this becomes the new matrix. So after getting this, what we are going to do, we are going to assign the binary weightages to the to the columns now. Okay, to the columns, because row completed, now we are going with columns. So again, you should remember that to assign the values from bottom to top, from bottom to top, from up down to up, down to up, bottom to top. You are going to assign the binary weights. Okay, so now we are assigning 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, because there are only 5 machines are there. Okay, so after doing this, now we are going to find out the column wise values, column wise decimal equivalents we are going to calculate. Say for example, 2 power 3 is what? 2 power 3, well, for let's take for the part number 10, 2 power 3 is, what is 2 power 3? 8.
8.
2 power 1,
2.
2 power 0, 2 power 0,
1.
1. So how much the value? 11. Okay, so now what we did, we just calculated in column wise. Column is previous stage, in the last step we did for row, now we did for column. Okay, hope you understood this step. Okay, is it clear how we got this 28, 27, 11 and all these things? Okay.
Yes, sir.
Okay, so now you can tell me what will be the next step. In the first what we did, we calculated we assigned the binary values from right to left. then we found the decimal equivalent row wise, then we arrange them in the from higher value to the lower value, we ranked it and we shuffled the rows. Then what we did, we assigned the binary weights from bottom to top, and we found out the decimal equivalent column wise. After doing this column wise calculation, what we have to do, what will be the next step? What will be the next step?
Rank the columns.
Yeah, correct. You are going to now rank it column wise. So column number, the highest among this is, so now you will get the answer. In this case, the values are three parts or three columns are having the same decimal equivalent, that is 20 part number 1 and part number 2 and sorry part number 5 and part number 7, they are having the same values. So this can be put easily as one group. Next we have 27 part number 2, part number 3 and part number 4. Next will be, next out of this is going to be part number, what will be the 7th rank, which cell will have?
6.
8th one.
8.
Next one, part number 6 will have 6, 8th rank. So now again see, part number 9 and 10, they are having the same decimal equivalent 11. So it's up to you to assign the values. Okay, so now this is how we have done. So now what we'll be doing, we should be, what will be the next step? We should be
Rearranging.
very good, very good. So now what I did, I have rearranged it based upon the ranking what we got. I have rearranged this. Okay, so now you can see that, there is a cluster formation happening here. See here, there's a cluster happened here. Okay, so these parts can be grouped and some chances are there for the next part. Okay, so now let's see what to do the next step. So next again what I'm doing, we have completed rows, we have completed columns. Next again we have to repeat this algorithm for the, with this as the matrix, with this as the new arrangement, we should assign the binary weights row wise. Remember the first step what we did. So now again, after doing rearranging the rows, after rearranging the columns, I am assigning the values to the rows from right to left. So now I am doing this and I am calculating the decimal values. Okay, you got this step? I understood this step.
Yes, sir.
Yes, sir.
What I have done is we have rearranged the columns. Then again I'm repeating the step number 1. Step number 1 is assigning the binary values, binary weightages to the rows, again calculating the decimal equivalent. So that I have done, and I have calculated the decimal equivalent as 1020, 1090, 900, 123 and 115. So can you rank this now? Can you rank these numbers from higher to lower?
1, 2, 3, 4, 5.
Yes, sir.
Okay, so is there any change in the ranking now?
No, sir.
Like is there any
No.
rearrangement is required?
No, sir.
No.
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 So
No, sir.
this is where you have to stop doing the iterations. So this is where you can stop, because even after calculating this decimal values, it is not possible for you to for any rearrangement. Correct? There is no possibility of any rearrangement of the rows. So you can stop here and you can start making the clusters. So when I rank it, it's going to be 1, 2, 3, 4 and 5. So what happens? The rank remains unchanged. So we can stop here. Okay, so this can happen in the second iteration itself, or there may be chance after doing this, after if it's not, if this condition is not satisfied, or if there is some possibility of rearrangement, what will be the next step? You'll be doing it for
Column.
very good, you're going to do it for the columns. Okay, so this is how the arrangement, the best possible sequence of arrangement is this one, because I could make this as one cell, but what happens, this many machines are left out. So imagine this, I can take this many components in these two machines and only one component in machine number 3 and the other 4 components in machine number 4 and 2. So this could be the final cluster. So machine number 1 and 5 can be put in one cell. Machine number 4 and 2 can be put in another cell. Okay, and the other components has to use all these machines in their own way. But it's the best sequence of arranging, best way of arranging machine number arranging is putting machine number 5 and 1 in one machine cell, and machine number 4 and 2 in another machine cell, and machine number 1 3 to be kept alone. So that could be the best possible way of arranging the machines in clusters. Okay, so hope you got this answers. So this is the best sequence. Okay, is it clear? So we are done. We are done with the rank order
Yes, sir.
clustering. We are done with the rank order clustering algorithm. So the basic thing required is to ensure that you know the values for 2 power 0 to 2 power 12 at least. Then you should always, when you are doing with the rows, first you should start with the rows, and when you are starting with the rows, you should be cautious to assign the binary weights from right to left. Then you should start with the columns. Then you should when then assign the binary weights from bottom to top of the column. Then you should be able to arrange the machines in the from higher value to the lower value. So once if you find any no change in the decimal values for ranking, when there's no change in the ranking, then you can stop the iteration there, and you can form the clusters. So that could be the possible way of doing it. And always ensure that when forming the clusters, you're putting your cell should be able to handle more number of components. So then it makes sense. Okay, so that's one possible way of doing the arrangement. So like this, there are three more algorithms you'll be learning. I taught you this algorithm in this class so that you'll be able to solve your digital assignment uh, quickly. So that's why I discussed this problem in this class. So this is your sample problem. This is your digital assignment which you have to solve for your digital assignment to be submitted on 18th. Correct? So this is your rank order clustering algorithm problem to be solved for the digital assignment. Okay, so here if you could see, this is the problem. I have arranged the values in the row wise, starting from right to left. And after doing this, we got the rankings like this. After getting this ranking, I am reshuffling the rows, and again I am doing it for the columns. Okay, then I'm again finding out the column wise decimal equivalent, ranking them, and arranging them. So when I proceed like this, I will be able to get the final cluster like this one. So this will be your final solution for the digital assignment. I'm not showing you all these things because I want you to do this as an exercise. Okay, so let's do, you please do this problem and submit as assignment. Okay, so that's for this class. Okay, so you can now, I'll just post your form, and after that we can wind up the class.